Hi everyone. Let's take a look at problem 6-4. It deals with expected return where we have a discrete distribution. Okay, there's some information that appears in this problem. We have different states of the economy, if you will, or states of demand for the company's products, ranging from weak to strong, and there's a probability associated with that demand occurring. That appears in our middle column. And then finally they give the information for the rate of return anticipated if this demand occurs. And with that information, we are supposed to calculate the stock's expected return, the standard deviation, and coefficient of variation. Okay, one key here is it's expected, and so we are going to use that approach. Now, I've worked this one ahead of time to save time in the demo, so let me bring some things to light. You can see here I've already just copied the information that appeared in the problem. Let's just bring some columns together. Okay, so we have the probability and then the return, and then we're going to compute a weighting, if you will. And how we do that is we multiply what we have in row A times row B. So let me bring that to light, and I'll hit an F2 to show you that all I did is multiply that number times that number. Once we have that, you copy it down, and then we can calculate the sum, right? Because these are weighting factors, right? So these are relatively small numbers as opposed to the return, because it's being weighted by the probability. And the reason why this all works out correctly is the probability equals 100%. Okay, so having said that, we're able to calculate the expected return by summing the probability times the returns for every discrete demand expected. Okay, now let's think about standard deviation. Let's come up with some titles here. Okay, what we could do is we could take the weighted squared variance from the expected rate of return. Now let me bring one to light and I'll walk through the formula. Okay, what I'm doing is I'm taking the return in cell E19 minus the expected rate of return that we already calculated. Now you'll see the dollar signs because I'm locking that in, so when I copy it, it will always pull from that cell. Then we take that, we square it, right? That's what the little caret 2 stands for. And then multiply it times C19. Now we could have put parentheses around the 2 in over here at the beginning. But the way Excel and most programming languages work, it understands that we need to do powers before we do multiplication, so it's not necessary. Okay, so once I do that, I get a weighted squared variance from the expected rate of return, and then I can copy that going down. Okay, now let's put a title over here. The standard deviation means we take the sum of all those weights and then take the square root. So let me show you what I've done here. And this time I did put parens. It's not necessary. In fact, I'll take it out. 26.7 is our answer. When I take the parens out, we should get the exact same thing. So we take, and I say parens meaning parentheses, we take the sum of the weighted squared variance from the expected rate of return and we take the square root. Well, another way to take the square root is to take it to a power of 1/2, right? And we do that, I get 26.7. Okay, so that's the standard deviation. And then finally they say, what's the coefficient of variation? I think I did the coefficient of variation right here. And that's pretty straightforward. All we have to do is take the expected rate of return and divide it by the standard deviation. And those are the three answers we're looking for on P6-4-12. So I'll bold the answers for you. And I hope you found this beneficial. Thanks, everyone.